to try to keep my time under 45 minutes here. I have 45 minutes. All right, so hello everyone. That's working, excellent. So who am I? If you are not familiar, and maybe everyone is here, I'm Adrian Black, and I play someone who knows what they're doing on the internet. I operate the channel, the two channels actually, Adrian's Digital Basement, Adrian's Digital Basement 2, where I specialize in fixing broken junk, aka old retro computers. The occasional game console makes it onto my channel as well. And what I want to talk about today is essentially that repair of this old stuff is not as hard as it may seem. And unfortunately, I'm not going to be able to give you some kind of smoking gun fix if you have a broken thing, but I want to sort of teach a little bit of the skills that I use to fix all this stuff on my channel. And let's just say that I've fixed a lot of stuff. So I think at this point my channel's got about, the main channel there is like 200 and something thousand subscribers, and I have a second channel with around 60 or 70,000. And I actually do this as a full-time living now, which is totally wacky because I'm 50, I'm almost 50. And the thought of actually quitting my job to do YouTube full-time as a job is completely ridiculous to me. And honestly, every time I have to fill out a piece of paper like a passport renewal application, it wants me to put my profession. I put content creator. How did I even get there? So yeah, how it started, right? So me, like I'm sure many of you who are in this room here, were a kid of the 80s or the 90s, some old bygone era, right? And that is actually me, 1983, using my Apple IIc. That was my VIC 20. My father bought that machine for me in 82, and he operated a video store and was able to get stuff wholesale. And that's how I first started figuring out, hey, computers are fun. And I was down in my father was a graphic designer also, besides operating a video store. And I'm down in his studio there, so his art books and stuff are there. And I had my little TV, and I would write my little basic programs and stuff. So that's all kind of how it started. And it kind of went from there. It was me in 86 there, and I had my Apple IIc, which is why I said that a second ago. Looking like a little pipsqueak, but I was total computer nerd. And in the 80s, computer nerds weren't as common as they are now, let's just say, right? You went to school, you had a lot of smart people, but they might be in some other clubs or whatever, but the computer guys were still like the minority, right? Looks like we won though, because like everyone here is a nerd, which is awesome. Nerd power. Anyways, I was a computer user, I played games, I had a bunch of discs, but I didn't know anything about how a computer worked. I was like most people. And to be honest, today, nothing is that different. Right? People use their iPhones or whatever, and they don't really know how the machine works at a low level. In the 90s, I ended up getting a job in the computer store, and that started, it was like an after-school high school job. And I started to learn troubleshooting at that point. Because, I don't know what it's like now, but when I went to school, they weren't teaching us troubleshooting skills in school. It was like book stuff, I don't know, history, whatever. But in the computer store, not an actual picture, that was just one I found on the internet, I repaired PCs. And up until that point, I never even used a PC in my life. But I started to figure out how to put my brain to work to figure out what might be wrong. But we weren't doing any kind of low-level repairs. We're swapping out motherboards or hard drives and things like that. So it's still very, very rudimentary compared to what I do now. And then after that, and believe it or not, sorry for the ridiculous photo, but it's a trope, right? I've had a career, and as I just said, I mentioned I left my job. I've worked for 30 plus years in IT and InfoSec. And it was a really great profession. I loved, the job, I loved the work, I loved the people I worked with. I loved everything about it, to be honest. And through all the IT stuff I did, I kind of ran the gamut, system administration, all the usual stuff. I was never a software developer though. I mean, what you notice here is at no point was I ever doing anything electronics at all. My entire career was just in an office and sitting behind a desk and using computers and telling people what to do and whatever. And this photo, if you watch my channel, you may know a little bit about what I do, and I do these videos from my basement. Well, that's my basement in 2014. That is how it looked. I did not have any retro computers at all. I'm not, unfortunately, one of those people who saved any of the things I had when I was a kid. Like those pictures of those computers and all the other things I had, all gone. So in 2014, my basement was empty. There was nothing in it except for just those few things. Life was very uncluttered. But in 2016, a friend called. I'm getting somewhere, believe me, with this whole story here. So my friend Dave called, someone I knew from junior high school, and he said, hey, someone in Portland, and I was living in Portland at the time, they're selling some old PCs at Craigslist, it's a really good deal, blah, blah, blah. You know, maybe you should go pick it up. And I was like, really? I guess, okay. Well, I picked it up. It was cheap, it was all in box, it was like a Micron, I think it was like $50 or something like that, never been used. And I thought, oh sweet, so it was like my first haul, right? And if you're into collecting, you know what it's like to pick up a haul. Well then, that, and that. So my empty basement was no longer going to be empty. But I realized something. I'm having a little bit of a reality check here, having brought home all this neat stuff. Stuff was broken a lot. And I realized at that point that, the stuff I was bringing home, it was really fun to kind of get back into the whole retro scene and like bring home this stuff, the halls or whatever, but man, things were broken a lot. And, to get a good deal, especially you might want to buy something, they're like, I don't know if it works or not. It worked when I last used it, so you get a good price. Yeah, worked when parked or stored, right? But the reality is, and that's actually a picture of a pet I bought at the store on Hawthorne Boulevard here for $10. And I knew it didn't work, but I wanted a pet. Ever since third grade, I played with a pet, and I was like, I really want one, but I was like, I'm not gonna pay this crazy money to get one. So I thought, okay, let me bring this home. And I thought, I didn't really know, but I was like, hey, it's not like the 80s anymore. You can't like bring your busted retro computer to an old computer store and get them to fix it like you could, whatever, in 83 or whatever that picture was taken. And as I mentioned, all of my job stuff that I had done up to this point, including the college, I wouldn't say degree, because I never got a degree, but the college work I had ever done was not in electronics, and this was the extent of my electronics knowledge at that point in time. If anyone ever used one of these things, it came from Radio Shack, my dad bought it for me, and it was one of those little kits you can, learn the very basics of electronics. That was it. And in the time when Arduino became a thing, I started to actually fool around with that a little bit. And when that photo of my basement where you could see there was I had a little oscilloscope and a few things there, it was really mainly because I started playing around with this stuff. And I found, I'd always been interested in electronics. And the degree I tried to get in school, never did, was computer science. And actually, funny thing is, like in hindsight, I think maybe I would have been better off doing electrical engineering. I should have done that. Because playing around with Arduino stuff, if you've ever done it, it's an amazing way to take what limited skills I had in programming, which is like basically nothing, and make a light turn on or a motor turn on, do some type of thing with, use a modern computer or a piece of hardware to actually impact the physical world. And it was interesting. But I still knew very little, and I blew up plenty of those boards, plugging in the wrong thing, doing whatever. Luckily, they socketed the microcontroller there, so you could have a spare set of those. But this was it. So remember, if you see the videos now and I'm fixing this stuff, this is what I was doing in 2012, 2013, 2014. I barely knew how to solder. Literally, I was. Yeah, I had a breadboard, and I was doing the little jumpers on there. But I mean, I had really the most rudimentary skills, even at soldering. I had a soldering iron, but so that I wasn't that bad, but nonetheless, So I just really didn't know what I was doing. So I started watching other YouTubers, Dave Jones, EEV blog. Huge impact in my life, and also Big Clive here. Both these guys, Big Clive, tears down light bulbs and stuff, and I'd go to the EEV blog forums that Dave runs, and there were people talking about, hey, you know, there are these new oscilloscopes you can buy, Rygal's, and they're cheap, but still $300. But I was like, oh, maybe I should get some of this stuff. And I like bought a multimeter, and I started buying some tools and things like that, and learning some of the fundamentals of how electronics work. And then my channel, if you go back to the really early videos, there's a few videos of me tearing down some light bulbs, but in 2017 was when I had my first actual repair video. And this video is still up there, and it was a Tandy 1000 EX that I got off Craigslist here in Portland for free, and it didn't work. And I had to start to figure out, like, and if I recall, when this one, you turned it on, oh, that's actually what it did. It just gave you a solid white screen, which is just sort of like no signal, basically. It's the equivalent of the black screen on the Commodore 64. And I had to start to put like the little I had learned to use to try to troubleshoot this machine. And the funny thing is, of course, I go back, and I'm sure any other YouTuber says that you go back to your old videos and it's like cringy. And when I watch this, I'm just like, oh my God, look at me, I'm just so terrible. But the cool thing is with this whole Tandy, is with my limited skills, I was able to figure out that the chip on the ones with the extra parts there, which is on your right there, actually was bad. It was the main chip for this machine. And the weird thing is that there was a guy in England who had bought up the entire stock of Radio Shack, Tandy Radio Shack, when they went out of business there, and had all of the chips from all the Tandy 1000 computers and every other Tandy thing on his eBay store. And I was able to, and you go back into this video still up there, I was able to buy this chip. And in the video, I got the new chip, which is the one on the left there, and put it in the machine, and it freaking worked. So I realized that fixing things like these computers that I was now starting to collect and like bring home in the back of the car, if I made one work again, I'm like, damn, it feels good. It feels really good to get these things working. And obviously I made a video about that Tandy repair, and I don't know if it's my very first repair on the channel, but I think it is really one of the first actual repairs. And that's how I sort of got on this track of like figuring out, hey, the repair part of retro computers and retro hardware we're dealing with here is actually really fun and rewarding. And everyone who's like into this hobby has a different niche or corner that they like. And some people love to play games, or they like a particular system, whether it's computer or game console or whatever it is. And me, I'd always, in this whole collecting I was doing with the stuff in the back of the car, I was realizing that as a kid, I wasn't well off, but I was obviously lucky enough to have a father who was able to get me a computer when I was very young. But I'd always seen other people with their computers and like, it'd be neat if I had that or had that. But of course I couldn't, we couldn't afford that, especially as a kid. So then I was able to finally get those things that I'd always wanted. And I'd never had a Tandy 1000 in my life, and I had some PCs and stuff after working in that computer store I mentioned. But the whole repair aspect of it was new to me, and the high that I felt in fixing stuff kind of set me on the path that brings me here to you today, sitting in front of you, doing my YouTube channel as a full-time job, and also somehow knowing what I'm doing in repair. So that's why I said, I kind of joked at the beginning that I play someone who knows what they're doing on YouTube, because I don't have a formal education. I never learned any of this stuff in any kind of school or book or anything. It was just simply watching people with videos and then playing around. So a little spoiler, think back to the picture earlier of my bench. It was almost completely empty. That's what it looks like now in the basement. I just took this picture, and this is one angle of the basement. Some people in here I know have been to my house before, and it's just like, everywhere you look, it's completely wild. But things have changed, but not that dramatically. I don't have a whole bunch of fancy test equipment. I just have a lot of stuff to use as tools for making videos and whatnot. But yeah, that's what the basement looks like now. All right. So what I wanted to talk about today is that the journey that I went on, the journey I went on of not knowing what I was doing to suddenly seeming like I know what I'm doing is something that I think anyone can do. And I run into people all the time in this hobby that they come to me and they say, hey, I have this thing, whatever it might be, electronics, vintage electronics, it doesn't work. Like, can you recommend what I can do to fix it? And unfortunately, I mean, if anyone does any kind of work like that in here knows that it's often not that simple to say, oh, it's definitely this one thing, and you can get it working, and that's all you need to worry about. But the process that I use to try to get to the bottom of what's wrong with this computer is something that I picked up just in the last several years doing the channel. And that's kind of what I want to go over a little bit today. This is the dead parts bin dumped out on my desk. Every time I fix something, I take the part that was bad and I throw it in this box. You just see on the top there, it says dead parts tell no tales. One of my viewers made that for me because I used to store the chips when I first started just in a little Tupperware, like plastic container. In fact, that Tandy 1000 I showed where they had the bad chip, that chip is in this pile somewhere. And there's actually another box off to the side with even more stuff. So that's not even everything. But it's interesting, I had never dumped it out before, the box, to look at it. I'm like, that is what I have taken out of computers and turned it from a non-working machine into a working machine. And it's funny for me to even see it. I took that photo literally just the other day. But that's where I just kind of wanted to highlight that, yeah, that's this journey that I went on got me to that. Anyways, so if you're wondering how you might get started in this, on the same journey that I was on, obviously taking into account that, YouTube channels, watching channels, very valuable. But what kind of tools do you need, or what do you need to do to even get started? Well, I always like to tell people that the most important thing that you need to actually fix this old stuff is your brain. And again, another stock photo, but by far the most important tool in your entire arsenal, and it's the one thing that makes us as humans unique in this world we live on, is the ability for us to use our brains to have critical thinking skills. And I wish I could read this to you, but the thumbnail on my screen is tiny, so I can't. So, but basically, use your brain to start to eliminate and think about what's wrong with the computer so that you can reduce the scope. I think if anyone in here has ever had a broken piece of retro computer hardware, whatever it is, you look at it and you go, I don't even know where to start, because it's this board, it's filled with chips and it's all super complicated, right? Well, your critical thinking skills can take you a very long way into getting started. And really, this other silly stock photo here is, I truly consider myself a detective. And I think if you think that way for yourself, if you're trying to repair something, that is, I can't even stress enough, more than any other tool I have in my arsenal is being a detective, to try to get to the bottom of the problem before I actually try to attempt to repair. And I love cop shows, especially the ones from England. So I watch those detective shows where they're trying to solve crimes and everything, and for me, that is just fascinating process to watch, because it honestly, I see endless parallels to the work that I'm doing. I'm just not solving a crime, while I'm solving the crime of a dead part that's keeping my computer from working. And so yeah, being that detective is so key. And I'm gonna get into some kind of thought processes here to kind of highlight this. Now let's take an Apple IIgs. I just picked this out of my behind, right, when I was making this presentation. The 2GS is a computer, came out in 1986. I'm sure you're all familiar with it, but if not, it's an Apple computer. It's got some good games, got some floppy drives, whatever, there's a picture of it. So consider a 2GS, and this is the block diagram for a 2GS. Imagine you have one in your collection and the floppy drive stops working. Well, there's obviously, when you look at this block diagram, at the bottom here, is the disk port, and that's where the floppy drives connect up. This is hypothetical, by the way, this is not based on any real anything. So you have to kind of start to think about using that detective work that I was talking about, what could be causing the drive to not work? Well, there's obvious things, right? You could have a bad disk, or you have a bad disk drive. But what's more important, actually, than even getting to that, if you consider those things, you've skipped ahead, because you have to start collecting evidence. And I liken this to when people come to me and they're like, oh, I have this computer and it's not working, and they just say oh, it has a black screen, and that's it, or it does one thing, but they're very vague on the details. if you think back to being a detective, the details matter. So going back to this example of an Apple IIgs with a non-working disk drive, well, what exactly is happening when it's not working, in air quotes? When you turn on the machine, does it try to load a disk? Like, does the light come on? Does the disk spin? Those types of things. Those are the kinds of details to even get you started to try to figure out where the problem might lie. Because again, trying to solve these problems is all about trying to get to the bottom of it and reduce the scope of this problem. That block diagram on the previous page here, there's a whole bunch of systems on here, and this is super highly simplified, but you got a whole bunch of things going on here. But when you think about it, and you look at this part again with the floppy drive, well, right away, you can start to eliminate things. And you can go, okay, well, the drive light, it doesn't even turn on. The LED on the drive when you turn on the computer. This is hypothetical, I remember this. But hey, you turn on the computer, it looks like it's trying to boot, but it doesn't actually turn on the light. Okay, well, first of all, you're like, oh, let me plug a different disk drive in. No change. All right, so now we're looking at this block diagram, and the floppy drive is connected to the port there, plugged into this chip, or whatever this block's called, IWM. But what can you do with your knowledge of the computer? Well, the computer's turning on, and you might see a basic screen come up, and it's kind of working. It just won't load a disk. Well, you can start to eliminate huge chunks of this block diagram, right? We know it's not, the sound circuitry, or the serial ports, or the CPU even for that matter, because it's turning on and it's working. Because I picked an easy problem on purpose because it's easier to talk about here. But so we're starting to rule stuff out. You're like, okay, well, the only thing that seems relevant to the disk drive is the port and the IWM, and then it goes into a black line that kind of goes to everything else. So let's just kind of ignore those other things out, all those other things, and we're like, okay, well, let's check out the schematics, which are the design files for this computer that talk about the entire circuit of the whole thing. And when you look at these diagrams, there's like 20 pages, and there's like wires and chips and signals everywhere. The whole elimination process of getting rid of all the other stuff on this block diagram, this high-level diagram, is important, because just going to schematics, you're going to be like, I don't know what to do here. I don't know where to start. So this is the actual schematics for the 2GS. Luckily, it's available. Schematics are not always available, and when they're not, you kind of have to start to reverse engineer things yourself, and it's kind of difficult, and it's very time-consuming. And that's why I'm a huge proponent. If anyone ever has schematics for something that's, say, rare, please scan them and upload them to somewhere like archive.org so anyone else can use them. But I went into the schematics for this particular theoretical problem, and we saw on the block diagram there's a box that said IWM. Well, there happens to be a chip, which I have an arrow pointing to, that is this IWM chip. Well, I happen to know just from experience that on the 2GS is the disk controller IC. It's what controls the actual floppy drive. And you look at this and you're just like, oh, there's so much, how do you make heads or tails of that too, right? Well, there's some conventions, and I wish I could make this bigger. Oh, I can't. Okay. There are some conventions that you start to learn just from experience of reading these types of schematics, where the things that are on the left side of a block, which is the chip, are typically inputs, and the stuff on the right side are typically outputs. But in the case of this, it's not always that, because stuff on both sides actually go in and out. But that is sort of the typical conventions. Well, looking at this, you might go like, well, I don't know where to go with this. You might think, oh, well, maybe this chip is just bad. Let me swap this chip out. The problem is this computer's from 1986, and Apple never even sold spare parts for this machine. Apple's methodology then was actually the same as it is now, where they're like, oh, the disk drive's not working, swap out the entire motherboard. Well, let's be honest, this is, you can't do that anymore, right? We don't have the luxury of just finding like another 2GS motherboard laying around. So we kind of got to try to get to the bottom of it. So you start to try to understand what's actually happening with what's going on around this chip. Well, if you look on the, I wish I could point. Oh, I can't, okay. So here we go. I should have mirrored my screen, to be honest. So on this side, which I said was the input side, we have these A signals and we have D signals. Well, when you work on computers enough, you start to learn that the A signals are address lines, the D signals are data lines, and these come from the CPU, the central processor, and that allows the CPU to communicate with all of the things on the computer, including this disk drive controller chip. So for some reason, the CPU, the connections between the CPU and this chip on these lines here weren't good, like there was a bad connection, for instance, then there's no way that the CPU would ever be able to talk to this chip to say, hey, load that disk. So what you can do is with some tools, which I'll talk about in a moment, you could just simply turn on a computer and look at those signals with an oscilloscope, which I'll mention briefly in a moment, that is. And we'll see if there's any activity. Is there activity on those chips, on those lines, I mean? If we have a bad signal, well, you're gonna have to figure out what's wrong with that signal. Because again, it comes down to thinking about what are the minimum things that this chip needs to work. Well, you need a communication from the CPU. But there's more. There's more stuff down here. And I can't read what stuff is, sorry, I can't read what things are. Anyways, there's gonna be a clock signal, which is like a timing signal. It comes from somewhere else on the motherboard. It's not really relevant where it comes from. But I think it's like a 7 megahertz signal. It says 7 over here, so you gotta make sure that's there. This chip can't work without that 7 megahertz signal. So you can check that. And then there's another signal. I get my mouse pointer correctly, there we go. That was clock there. There's this dev signal. Well, the one thing that's really interesting about these chips on any computer and any game console is these things sit around doing nothing until they're called upon to do something. And in the case of what we're doing here, we need to boot. So something is telling this chip, hey, we're ready to boot the OS, start reading from the disk drive. Well, on this chip, it's called the dev signal. I mean, I never really looked at this before, but I just know from experience. Dev is this chip enable signal, a chip select signal. It's what tells this chip, hey, pay attention. The central processor, the CPU, is talking to you. You need to respond. And it's that signal right there, that dev signal, that does that. So again, if you're trying to troubleshoot what's happening, you need to look at that signal, this chip select signal. Is it there? Turn on a computer, make it boot a disk. Do you see activity on it? And if you didn't, aha. That's kind of a eureka moment, to be honest. Whether this chip is good or bad, we haven't identified that yet, but whether it's good or bad, if you are missing this chip enable or chip select signal, it will never work. It's impossible. And the same for all these other signals. So that's part of this kind of evidence collection. We're going through and we're checking, okay, yeah, what does it need to work? Okay, we need the address lines, we need the data lines, we need the chip enable line, we need the clock, we need the reset signal. There's a reset signal in there as well. Check all those. Okay, theoretically, say they all look good. And you're like, okay, but it's still not working. But they're there. You know, we turn on the computer, they look good. You see the going up and down, you know, all that. Well, then what about the stuff on the other side? These, there we go, the output signals. Now, we don't really know what these do because, like, it's not clear. There's no, like, technical information for this that says, hey, this signal is that. But we can kind of infer from this that the signals make their way over here to this J something connector. That's the actual physical connector that goes to the floppy drive. Well, again, some more evidence collection we're going to be doing here. Do we see any activity out of these signals here when we try to boot the computer? And there are these EN signals right here. These are the actual signals that come out of this chip that say, hey, disk drive, turn on, you know, turn your LED on, start spinning your disk or whatever. So try to boot the computer, doesn't see activity. So again, we're still like kind of collecting that evidence. We're trying to figure out, before we're making any repairs, taking anything out of the computer, we're still in this investigation phase, let's call it. Say you see that activity on these signals. Well, then maybe there's a problem between this chip, these traces here, these are like, you know, actual traces on the motherboard, and this connector that's on the back of the computer that the disk drive's plugged into. So you can take a look at those pins, like this enable signal goes to whatever, 17 and whatever, these pins here. Look at those. Do you see the signal there? If you see it here at this pin, but you don't see it at this pin, we know there's a problem on the motherboard somewhere. It's like a broken wire, so to speak. Or maybe the actual jack is bad as well. But you have to keep going further than that. We're not even done. You're like, what else does a disk drive need to work besides some signals to tell it to turn on? Well, you need power. And you see there's like plus 5 volts. I don't know, there's ground, plus 12 volts. So I have the different voltages right here. You gotta like check those. So again, we're still in this whole evidence collection phase. And only once you've kind of gone through all of this stuff can you make the conclusion, well, okay, I see all of these signals, I see the voltages, I see them on the actual port. Well, maybe your disk drive is physically bad, the one that's plugged into the back of the computer. And not everyone has the luxury of having like 10 disk drives to try a different one. But these are all the sort of steps that I'm going through, that I go through, and you should go through to narrow down the scope. This huge complex system with a motherboard filled with chips and all, it's like, I don't know what to look at. But you're like, wait a second, just using your critical thinking skills, you start to rule stuff out. Backing up slightly, imagine we have this chip here, and we don't see that chip enable, that dev signal I was mentioning earlier. That's the one that tells it to pay attention. We don't see that signal. We see no change. Well, immediately we know. We don't know if the chip's bad or not, but what we know is it can never work. And I said that earlier. Well, what you have to do is you follow this trace back to wherever it comes from, something else on the motherboard, and that other thing is what generates that signal, and that could be your problem. So we've gone from thinking, well, I think it's this chip that's bad, which is impossible to even buy, to, it actually might be something else on the motherboard, which unfortunately with this computer is not good because that other chip is impossible to get as well. But point being is like this process that you should go through to kind of get down to the nitty gritty. And you may not really know how floppy drives work. You don't need to know how like the actual data is written onto the drive to know that some of the basics of how things on the computer work. And believe me, the methodology that I've sort of talked through with the way the chip is saying, a signal goes to the chip to say, pay attention, it's the same on everything. From this modern Mac, whatever, laptop here, to the oldest computer, it's exactly the same. Every chip in this computer sits there waiting for it to be told to listen. And then a signal comes to it from somewhere else and says, okay, pay attention, and then it pays attention. Typically, you may have heard the term glue logic, GLU. That's what generates those signals typically, but anyways. Now, if this chip, if you see all the signals, everything looks good, and you're like, I tested a different disk drive, and it's still not working, well, then there's probably something wrong inside this chip. And, unfortunately, you have to find a way to swap it out. But that's sort of like the exercise that I go through whenever I encounter a system that's not working. Whether I've used it or experienced it or not, there might be no schematics, there might have been a computer I've never used before, but luckily some of these kind of fundamentals that I've talked about are literally the same on every system. And unfortunately, with a lot of machines these days, modern stuff, like there are no schematics available, but what you can do is you can often look up a chip, and there's maybe a data sheet, which is a technical document for the chip that might explain like how all these parameters work, like how all the ins and outs and all the stuff that kind of went through work on that chip. And you kind of have to start to put your brain to work and think, okay, go through the exercise. What are the things this chip needs to do its job? And you kind of start to put those pieces together. If there's no schematics, you might have to even use pen and paper and like start drawing out some schematics and things like that. Do it, manually. But we were able to eliminate this relatively complex system and get down to all the way down to like either this IWM chip is bad, or one of its signals that go to it are bad, or maybe that chips enabled signal that comes from somewhere else is bad. So we've kind of gone from like this whole complex computer with a ton of chips down to just two possibilities that are bad. Well, maybe more if you think about like there's a missing voltage, power supply, right? So it can kind of spiral out of control very quickly. But this exercise is literally the same no matter what's wrong. You always have to start somewhere, and you have to kind of go through this detector process. And what I really like to talk about, and I'm sure if you see my videos, I talk about this, is this diagram here is what I call a cannon. And it's not what I call a cannon, it is a cannon. And one of the easy things to do when you're trying to repair something, especially if you haven't kind of thought through what's wrong, is what I call the parts cannon. Not a term I invented. It's especially big in the car repair industry, because these days cars are very computerized and people don't know. A lot of techs maybe don't use their critical thinking skills to try to troubleshoot a problem, and they'll just like say, oh, the diagnostic tool says, EGR, sensor, whatever, let me put a new sensor on there. Without doing any real troubleshooting, just throw a part at it. And they might do that, and oh, that didn't fix the problem. Throw a new valve, and this, that, and eventually they're like, you know what, the computer's bad, and the whole computer in the car is bad. Throw that out there. Well, what if, going back to this schematic for the 2GS, remember I mentioned like, what if there's a bad connection, a bad wire between two things? What if your car had a metal steel wire, and they put all these new parts in, and the reality is it's just a bad wire. And if they just did their troubleshooting skills and eliminated, they would have found it needed no new parts. So the parts canon is very easy to do because it does work in some circumstances. Like we might have swapped out that 2GS IWM chip and then got a working disk drive out of it because it was a lucky guess basically. But when we're talking retro computers here, not car parts you can buy from the O'Reilly's, around the corner. We can't just get these parts easily unless you have a spare machine to keep swapping parts around. But the reason why as well that I think that the parts canon is bad for retro hardware that we all work on is because removing stuff from motherboards is dangerous. It's the most dangerous thing you can do as a novice to a piece of equipment. And in this picture here, I'm removing a CPU from a Commodore 64, and I'm having to do a hot air and use my desoldering iron, and I have to use kind of expensive equipment to do it. And I've done it enough to not cause damage to the computer, but I've worked on enough machines that unfortunately, people who didn't have the right techniques at hand tried to remove something from a computer that they thought were bad, and they actually caused damage that was unrelated to what was causing the computer not to work. Like they were trying to fix a problem, they accidentally created a problem. And that's because there's like those traces, those little wires I was talking about that run around the motherboard if you've never looked at a computer, and lifting up a chip, taking it out of the board with force will just rip those right out of the board, and it might be under the chip and you might not even realize what you've done. And you put the chip back in and now you're like, it still doesn't work, I don't know what to do. And I've gotten computers like that where I go to repair them and then I have to uncover and unravel the damage that was caused accidentally by work. So that's why I say removing parts from the computer, unless it's in the socket, of course. You just pop it out of the socket. That's generally safe. Although, who has not taken a chip out of a socket, put it back in, and accidentally bent a pin underneath and not realized it? So even that is, because if you're trying to solve a problem on a computer, there may be one fault, and you do something like take the chip out, put it back in, and bend a pin, you've now created an additional fault that wasn't there that you now have to troubleshoot on top of the one that was already there. So that's why I say the parts canon, by just swapping things willy-nilly, unfortunately can result, and even with me, I try not to do this for the same exact reason. It can unfortunately result in more faults, making it more harder or more difficult to repair. So going back to that analogy of like the detective thing, it's so great to try to like rule everything out you can and get down to the, this is the most likely area, it's gotta be in here, and then maybe you have to start guessing at that point and take a chip out and do things like that. But yeah. Now, this is a picture of some capacitors here. Here, I have a photo right here. No, this is my dead parts. What do you not see a lot of in here? Capacitors. There are capacitors in here. There's a bunch of REFAs. It's these yellow ones in here. These guys, they blow up and they put smoke in your house. It's really horrible. And there's a cap down here, the green one at the bottom. Unfortunately, it's in the mindset of a lot of like casual repairers, and I don't blame anyone because this is like kind of common on the internet. People are like, oh, recap it. That'll probably fix it. Of all of these computers that I've fixed, I don't even know, hundreds and hundreds of computers, I think there's only been maybe 1 or 2 times when the problem was a capacitor that was actually keeping it from working. And ignoring the fact that, yes, these REFAs, these are the yellow ones that let the smoke out, yeah, those you gotta change, right? They're terrible. And here's a picture of a Macintosh, and anyone who works on like stuff from the 90s knows those little silver cylindrical things. Those leak and destroy everything. So yeah, there are times when you gotta change caps because they leak and they keep your computer from working. But primarily I work on this stuff from the 80s, and the capacitors that are in those machines are so high quality compared to even modern stuff you can buy today. That's where I'm saying there's only been a couple times when I actually had a cap that was bad that I had to take off to fix the computer. I mean, and out of hundreds of machines. So I try to tell people you shouldn't jump to the conclusion that caps are your problem unless it's a known issue that definitely, like I said, with the Macintoshes and Amigas, and there's like a bunch of things where like if you go online, people are like, oh yeah, those caps are always leaking and they will keep your computer from working. Yes, but if you're talking about like a Commodore 64, recapping a Commodore 64 is literally pointless. It's almost never do those caps leak or go bad. So that's why, like, I think when you're going through your evidence collection, your investigation, Sure, if you know it's bad caps, okay, you can start there, no problem. But if it's a machine that's not normally a thing, then yeah, don't assume it's caps. That's what I do at least. And when it is a cap, I'm always like, wow, that's crazy. Okay, so we are in this golden age right now. Okay, it's a double-edged sword. Retro stuff is hot right now, which makes prices really high, right? You all know that, you go buy something, it's like so expensive. But the golden age we're in, this like renaissance, so to speak, is that you can buy incredible pieces of test equipment for so cheap. This particular device is a Zoe 703. It's an oscilloscope and a multimeter in one. If you have no test equipment, you've never done a repair in your life, this thing, which is like 80 bucks, I bought one, not a paid sponsorship because I just paid my own money. It's a great device. It's a dual channel oscilloscope. The oscilloscope is what you use to actually look at the signals. When I was going back to that 2GS when we were going through the evidence collection, you want to see if that chip enable line, a chip select line is telling the chip controller to turn on. You use this thing and you like probe the board and you turn on the computer. You can see the signals. You're like, it allows you to visualize what's happening inside the computer. That's why oscilloscopes are so powerful. And 30 years ago or 20 years ago or even 10 years ago, they were quite expensive. But like 30 years ago, you spent thousands of dollars on one of these. And now it's something that's like this size. I should have brought it as a prop, to be honest. But beyond that, it's also okay, 5 minutes. Beyond that, it's also a multimeter, which means you can test for voltages and stuff. So like all the repairs I was talking about with the checking for that bad chip on the 2GS, you can do with this $80 piece of equipment. It's amazing that we're living in a time when that is possible. And I get this a lot. People are like, hey, I don't know how to use an oscilloscope, and I don't know how to use a multimeter. And yes, absolutely, there is a learning curve with both of those. Luckily, we have YouTube. I have not made a video personally about how to use these things, but there are plenty of tutorials. I just did a quick Google search and this stuff came up. So if you're gonna think about getting into any repairs, I highly recommend get one of those dual purpose, $80 things or whatever, watch some videos, take a computer that works, and start probing around and looking at signals. You'll learn how to do that stuff in these tutorial videos, and then looking at what a good signal is on anything, game console or something that's old, of course. It's easy with old stuff because the chips are big, the pins aren't tiny. So look at what's good. You kind of start to get a feel for what's good. And if you go back to the car analogy, you have a car, you as an owner of your car, you know what your car normally does. And when it starts doing things different, you're like, what's going on? And you can go through this detective thing I was talking about with the Apple 2GS to try to start to figure out what's wrong with your car. But again, using these tools on your computer, you can be like, oh, okay, I kind of know what a normal signal looks like. And then when you're probing around on there and you're like, that looks different. Okay, so there are some basics as well that I've learned and that I think is really good to take to heart if you're trying to repair anything, is that there are some basics. The very first thing any electronic thing from your cell phone to this laptop to anything old needs is you need power, you need voltages, right? So are they okay? You can use that multimeter on that $80 thing to check those. Is there a clock signal? This is that 5 megahertz or 7 megahertz signal on the 2GS that goes to that disk controller chip, but every piece of electronic needs a good working clock, so you can check that with the oscilloscope. You can see, hey, it's working. And is it stuck in reset? Old PCs have a reset button on them? Well, modern stuff, like this Mac, doesn't have a reset button, so to speak, but there's a circuit inside that takes care of that for you when you turn it on. It resets everything in the computer when you first turn it on, and it comes out of reset, it's called, and it starts to run. Well, if you're missing any of these things, there's no way your device is gonna work. It's impossible. So using that tool I mentioned, you can look for these things, and you can go online and ask in the forum, hey, what's the clock signal on an Apple II? 1 megahertz, 1.024, whatever. You can look at that with the oscilloscope. You can check the reset, you can check the voltage. There are a few things as well that you can do poking around. Remember I mentioned the address data lines, and this is in a lot of my videos I talk about this. You might want to look and see, hey, are any of those signals stuck? Like, they normally are going up and down, I don't know what it's doing. You can't really, it's not the matrix, you can't read that stuff, but it should be going up and down. Is it just always 0, always 5? Those are good clues, right? This is all your evidence that you're collecting. Try to figure things out. If it is stuck, well, maybe try to figure out where that signal's coming from. And then you can kind of go from there. Learning how to read schematics is a skill as well. And I know you look at this and that's a schematic from a monitor or something like that. You're just like, there's so much stuff in there. But you know what? Once you kind of start to think about that block diagram on the 2GS I was showing, or this is for a CRT, they have block diagrams as well, and you can use that same elimination strategy to try to like figure out where on the schematic you should look. And in a monitor, you know, you're like, oh, well, I mean, I had there's a use case or something coming up here that I talk about, I don't have enough time, but basically, you're like, oh, it's, you know, I don't know, the vertical retrace is not working, you're stuck with a line. Okay, well, it's that block that says vertical. Well, you go back to the schematic and you like find the vertical stuff and you're like, that's it, that's what I gotta look at. You can kind of eliminate the rest. And again, it's reducing your scope. What was that? Oh yeah. Anyways, and that is it. So I have like the channel stuff and socials or whatever up there. And I don't think we have time for Q&A and anything, but if you can find me on the floor if you want to chat, and you can also email me on my channel about page or whatever. Chat with me. So I hope this was helpful in any way. So,